Okay, so we can start. So thank you, first of all. Then it's been a long day probably and a long weekend, and I don't want to boring your evening. So first question: who use TypeScript in in your job? Okay, not so much. Probably the slide is okay in this case. And in this case, who work with JavaScript? Okay. Third question: why you are here if you don't know TypeScript and you don't work with JavaScript? Good. Okay. So when I start to think about this talk, I was thinking, okay, but the audience in front of me, how much know about TypeScript? And so I create something like this. Let me show you. This is all the slide, okay, with a lot of stuff, because I don't know how much, what do you know. So I want to start with a story in this case. Start presentation, and okay. If you don't know TypeScript born in a Microsoft repository in 2012, okay? And continue to be supported by Microsoft. It's not like Word, Excel that doesn't work, but this work. Depend on the developer sometimes. First things that you have to learn is that if you know JavaScript, probably you know a bit of TypeScript, okay? And it's not a bad things. Then there is a lot of people in the JavaScript ecosystem that hate TypeScript. I don't know why, because they can continue to use JavaScript without any problem, but this is the reality. The idea of TypeScript is not to complicate your job, but sometimes we love to complicate it, but it's only our problem because we are developers and sometimes we don't know how to spend our time probably. And last but not least, remember everything that JavaScript is a friend for TypeScript. So if you love JavaScript, don't have any problem because you can continue to use JavaScript, but if you want to step over, you can use also TypeScript. So now, in these days, probably TypeScript is a superhero if you know how to use it, but maybe not, depends. So today I wanna start to teaching something about it to understand if you think it's a hero or not. First of all, a quick introduction, but Davide already did, so we can skip. Probably it's boring. Let's start with the fight, okay? Typically, developers love compare two stuff. For instance, ban with Node, and today I wanna compare TypeScript with JavaScript in a different way. I want to start with JavaScript, okay? Imagine you are a pilot and you have to win the Formula 1 Cup, okay? JavaScript is something like this, okay? You can drive in a circuit where there is not so much rule to drive your car. And it's all in charge of you. So you are a professional driver, so you probably know how to drive your car. And this is a simple example of JavaScript code, okay? You have some rule like a function, a name, and parameter called name in this case, but you don't know what this parameter is, okay? And then you can do other stuff. This is an idea of JavaScript, okay? And for me, TypeScript is something like this, okay? You are a common person that have to drive to go to work or to meet friends. And you have to drive in a traffic jam or something like this. And probably you're not so lucky and there is an old man with the cap and the panda in front of you. So TypeScript is something like this. Is a road where you have some rule to follow. For instance, a stop or a traffic light or something like this. In fact, if you try to convert the previous function in TypeScript, This is the result, okay? There is the function, the main, the parameter name with the type, in this case, and you can also say, okay, this function is a void function, so it doesn't return anything. And then you can do whatever you want. And in this way, you can have some rule for all the team. And if another person need to use your function, know what this function expects. Just to understand better TypeScript and JavaScript, this is an idea of TypeScript and JavaScript. TypeScript is a superset built on top of JavaScript. So if you have JavaScript code, it's a valid TypeScript code. You can use JavaScript inside your TypeScript code. If you want to use TypeScript inside your JavaScript code, you have to convert it in JavaScript, because every TypeScript file will be transformed in JavaScript with a compilation. How? In this way. So typically, if you want to work with TypeScript, you have a simple TypeScript file with the extension .ts, okay, where you can put your code, classes, interfaces, function, whatever you want. Then, using a compiler, in this case, you have to do the compilation or transpilation, okay? TSC is the official compiler for TypeScript built by Microsoft team, in this case, that convert your TypeScript code in JavaScript code. And what happened, the result is that you have a vanilla JavaScript file with the .js file. Remember, you can use TypeScript, but in your browser or in your Node server, run only JavaScript, okay? So you must know JavaScript to use TypeScript, because all the magic of TypeScript after this phase disappear. So if you think a variable is a string, but your server return a number, it's your business in this case. So an idea when you can use TypeScript. So if you have a big project and many developers that need to work in this project, probably this is better. Okay. Use TypeScript is a good idea, because the type system can help you to prevent some error at build time and not at runtime. So you don't have to wait for the customer call. Your system doesn't work in my browser, whatever you do, something like this, okay? If you have a lot of people that work in a project, using types can help you also to understand what happened. Maybe a feature built by a person need to fix by another 1 month ago. Using types, you can understand what the function accept and what need to return, for instance. And it's not if you use only JavaScript, the problem is, okay, I have a variable that is with the type name, but maybe we call with, I don't know, a number. It's a bit difficult to understand sometimes, this tricky. If you are building shared library for your team, using TypeScript can help you, but depend. If you are building shared library for a company, it's a good idea to use TypeScript, because you can also have an idea of what's happened in the library. But if you are building something performance library, depends. If you have strong type application, it's normal to use TypeScript in these days. When it's better to use JavaScript, okay? If you have a lot of dynamic objects in your code base, sometimes TypeScript is a pain in the ass, okay? And probably if you need to use a dynamic object, the flexibility of JavaScript is, for me, is better. If you have a small library with the performance purpose, okay, use JavaScript is probably the best solution, because you can have the control of what is the real JavaScript that run after in the browser or in the server. For instance, for this case, you can create your real code with the JavaScript and expose a file that indicate which is the signature of your function. So if someone decides to install this library in the project, can have the intelligence if they are using TypeScript, for instance. Side project. If you are in your room, you can use JavaScript, TypeScript, whatever you want, but in my case, I prefer to use TypeScript, just to understand. So, a bit of fundamental, okay? First, if you already know some a program language with a type, probably you already know all of this, okay? You can use all this type with TypeScript, so number, string, boolean, big int, object, function, array, and symbol. The result is that you can assign a variable to number, string, boolean, and so on. And then if you try, for instance, to assign a string to a number, you will receive an error and compilation, but also in your Visual Studio Code or WebStorm, whatever you are using. There are some strange signatures sometimes. For instance, the array could be declared in this way, so you can use the type and the square bracket, or using directly the array, for instance, or the function. In this case, the function is a simple function without an idea of what is the parameter, but you can also use this kind of signature where you are saying that, okay, this is a function with 2 parameters of type number and return another number. And then you can create your function without any problem. You can use also symbol. Symbol is a native type in JavaScript. Okay. Then there are also null and undefined. If you don't know the difference between null and undefined, this beautiful Stack Overflow image help you to understand which is the difference. Why there is these two types? Because in JavaScript, null and undefined are different, okay? So you can describe your variable also with null and undefined. If you try to assign undefined to a nullable variable, or vice versa, you will receive an error. If you are building an object, for instance, in this case, this is a Sugar syntax for an object. You can also use the question mark to indicate that this few property is of type string, but could be also undefined. For instance, in this case, I can assign the O variable to few with undefined. Other two difficult types to understand in TypeScript. So any and unknown. I want to start from any, okay? When you are using any in TypeScript, you are saying, okay, TypeScript, stop to work. I know what I'm doing, and it's my business in this case. So you can do this. For instance, you can create a variable of type any and assign true, a Boolean value. Then you can call the trim, the reverse, and the split. These three methods are not methods of the Boolean type, okay? It's a method from the string. But what happened? TypeScript does nothing for you, because you say, okay, is any, it's not my business, it's your business. This is what TypeScript say. Then you can also try to assign in this case, an any variable to a number. But in reality, this is a Boolean variable, okay? And you can do this without any problem. And then you can also create a simple sum. Okay, this is a problem of JavaScript, that you can do all this stuff. It's not a problem of TypeScript. But what happened? Good luck in production, okay? Why? Because in this case, you are saying to TypeScript, okay, I know, but if there is a problem, it's my business, not a TypeScript business in this case. What is the typical developer behavior? Okay, when start to fight with the compilation of TypeScript, so there is something like this, we try to use everything. And in this case, probably it's better to use JavaScript and not TypeScript. Please don't use any if you can. There is a lot of rule for the linter, for remove, for don't use any, and please use this rule. So if you can, use unknown. What is the difference from any with unknown? Okay, unknown is something like a policeman for TypeScript. Okay, if you use unknown in this case, you can assign whatever you want in an unknown. Okay, but you don't know what is the value of the variable in this case. So if you want to do something with that variable, you have to check and be sure that that variable contain the method or is of type number or something like this. For instance, if you try to call the trim in this case, TypeScript show you an error. So in this case, my unknown is of type unknown, and you cannot call the trim. I don't know if trim is a valid method for your object, for your variable in this case. The same if you try to assign a number to you can try to assign my unknown to a number. And this is the error. How can you fix this problem? You have to check if, for instance, in this case, the my unknown is of type string. In this case, for instance, using the if and the type of, you can check if the my unknown is of type string. And inside of this branch, okay, my unknown is of type string for the type system, but also at runtime for your JavaScript code, if you are inside of this branch, my unknown is of type string, and you can call the trim, and you don't receive any error. The same if you want to try to assign the my unknown to a number. You can check if the number is if the my unknown is of type number, and in this case you can assign the my unknown to a number and call the sum in this case. This is important because with unknown you can prevent or you can check before the call if something exists in your variable, and you have to handle all the possibility of to get your business logic in this case. Okay, then it's time to move in a object-oriented word, but it's not an object-oriented word. You can define your custom type, okay? If you are working with JavaScript, probably you have a lot of DTO from the API, and you have to convert them in some way. You can describe your types using type and interfaces. They are pretty similar, okay? The difference is the syntax and another stuff. For instance, this. You have to remember that interfaces in the same file, you can declare the same interfaces many times. For instance, you can create the interface rectangle with the width, and then in another part of the same file, declare the interface rectangle again with another property, in this case with an 8. The result is that the rectangle contains both the properties in this case. So what happens is that for you, TypeScript merge the two interfaces. It's important to know this kind of stuff because it's a bit tricky, and if you don't know this, you can create the same interface in the same file, and you don't understand why there is the same there is a two property that for me maybe it's stupid in this moment that there is two property from two different interfaces. Last but not least, classes. Okay, classes are part of the JavaScript part of JavaScript, so you can use them without any problem. The difference is that you can create the member visibility, so you can use public, protected, and private. You can create method without any problem. You can create getter and setter. You can use the static method or static variable, and you can also implement or extend implement interfaces, extend classes or abstract classes. This is a simple example. So there is a shape class in this case. You can use you can declare the property in two different ways. You can decide to declare the property and in the constructor assign the property to the parameter, or there is a sugar syntax. In this way, you can say, okay, I want the rectangle variable property in this case, and using the public, the private, or the protected visibility here, you can decide, okay, this is a parameter, but also a property of the class. Then you can call your method or the getter and setter. And this is the result, pretty simple. Okay, this is the basic the fundamental. It's time to go a bit in advance. So, types are a bit strange. So imagine you are a pizza restaurant, and in your pizza restaurant there is only one customer, the Ninja Turtle, and you don't want to describe the ingredient like a string, because a string could be whatever you want. You wanna that the pizza ingredients are 4: flour, mozzarella, tomato, and pepperoni, okay? Using literal, you can describe a type, and these are not string, but are real type. For TypeScript, flour, mozzarella, tomato, and pepperoni, in this case, are real types. What mean? If you try to assign flour to a pizza ingredient, is okay. If you try to assign tomato to a pizza ingredient, is okay, but what happens if I use mozzarella, for instance? TypeScript raises an error, okay? Why? Because mozzarella is not a possible real type for the pizza ingredient, okay? And this is important because you can be strict with your type and describe at the best how you expect the value of this kind of type. But with literal, you can also do magic stuff, probably. Imagine you have 2 literal, one with type name and the other with type surname. Name contains John, Jane, and Jack, and surname Joe, Dane, and Black. You can use a literal, you can combine the 2 literal and create a full name type that accept in the first part the name and in the second part the surname. So you are creating a full name type that accepts all the combination between the name and the surname. So then you can describe, for instance, you can call John Doe full name with John Doe, Jan Dane with Jan Dane, but if you try to call John Blue, you receive an error, because John Blue is not a possible type for your full name in this case. I know it's a bit strange, probably, okay, and the developer love to drag a lot around of this, but when you understand how this works, you can create a lot of beautiful utility. Image, you can also describe, for instance, an RGB CSX variable in this case, because you can use the number as here you can use a number, and with the command you can say, okay, this is a number, command, number, command, number. And you can describe an RGB color in this case. So then you can also intersect some type. So you have a person, for instance, and an address, and you want to create another type, for instance, person with address. But you want to use the person and the address types already created. In this case, for instance, I create a pointer 1D with the X property. Using the AND, okay, you can build the point 2D, for instance, using the point 1D and the Y number, in this, the Y property. The same for the point 3D. So using the AND, the intersection, you can merge together different type and create a new type that depend on another type. This is a common practice if you are using TypeScript. But then there is also an union, okay? How many of you love pizza with pineapple? Raise your hands. Good Italian people. Okay, in your dish, you want or a pizza or a pineapple, but not both together. You can describe this with a simple literal type, and the pipe permits you to say to TypeScript, okay, dish or is of pizza or is of pineapple. Then, using, for instance, you can build a simple function order that accepts a dish, and using a switch, you can check, okay, dish is of type pizza, I can return a pizza. Dish is of type pineapple, I can return a pineapple. Pretty simple. Here it's not visible, but if you are in Visual Studio Code, if you wrong type pizza, you receive an error, because TypeScript understands that dish is of type pizza and pineapple, and here the case use only the type in the literal in this case. Okay. This is also a common practice in TypeScript because sometimes you have a different image and you have a different shape that arrive from an API, and there is a discriminator in this object that say to you, okay, this is this is a square, this is a circle, and you have to decide which is the calculation that you have to do. Then there is this beautiful and strange type called never. Okay, if you think about the previous function, okay, I create the order that use the case of pizza, okay, in this case the case of pasta, but in this case there is any case for the sandwich. Okay, using the never you can prevent this mismatch. Okay, what happened in this case? If you add, for instance, a new dish, you want to stop the compilation, the transpilation of your code, where you don't have handle all the possibility of the dish in this case. Never is the type that do this. Never is a bit strange because you cannot assign nothing to never. For instance, if you try to assign a any to never, you cannot. But in this case, if you follow the flow of TypeScript, TypeScript understands that here dish could be of type sandwich. Okay, sandwich is not assignable to never, and for you there is an error. Probably I can help you to do this here. Okay, as you can see here, string is not of type never. Okay. But what happens if I add case sandwich, return sandwich, return sandwich? Now, never, it's okay. This is important, for instance, when you create some function like this to prevent the compilation if you miss some some case for your switch, for instance. And probably later we have other example for this. But remember, never is a particular type used to be sure that you already use all the possible case in your switch. And this is the result. Another important stuff in TypeScript is the control flow of your code base. Now start to be a bit tricky sometimes. So there is an assertion function. What is an assertion function? It's a simple function that accepts something and return this strange type with the asserts. In this case, there is a condition and a message. Okay. In this case, if the condition is false, the assertion raises an error. Else, continue the execution. Assertion is used to check if maybe something is like expected. Else, throw an error because there is a problem in the data and I cannot continue in the execution of the code. For instance, in this case, assert, if you try to call assert with an empty object, there is no error. The same if you call with a number. But if you try to call with undefined, you receive an error and there is a kaboom at runtime. It's important because, for instance, if you create a type person with the name, and then you have for instance, in this case, a variable that could be person or undefined, you can create, for instance, an assertion function that accepts a person of type undefined or person. And the result is that, okay, if I call this function and I raise an error, in this case, person is of type undefined, else is of type, in this case, person. Then you can create two different functions. In this case, print person without check and print person with a check. Probably, if I copy this and go to here. This is what happened, okay? Imagine in some place of the code there is something that can set this variable, okay? But what happened here? If you try to call person, in this case, person could be undefined. So I don't know if I can call person.name. So TypeScript try to help you to understand, okay, or you check if person is not undefined and I call person.name, or you have to use the common approach as all the developer does. But now you know the assertion function, okay? What happened here? If you try to call the assertion, here TypeScript know that person could be of type person or undefined. But what happened in the line 17? As you can see, person now is of type person and not of type undefined. So using an assertion function, you can check if the variable is like expected, and if not, raise an error, else continue to the flow. This is the easy way, so kaboom, and something happened at run time. But you can also control the flow of your code base using typeguard. What is a typeguard? Is another function with a sort of is with something at the end as a return type. This function is used to split some, in this case, some union type. In this case, I create a square and a circle, and the kind is the property used as discriminator between the two types, okay? And then I create a shape. Shape could be square or circle. So using the function isSquare, you can check if the shape is of type square in this case, or using the isCircle, you can check if the shape is of type circle. And then you can build your area function. Copy this and go again here. Yep. Okay, if I go there, okay, here shape is of type shape. After the isSquare, okay, shape is of type square now. It's not of type shape. And TypeScript know this, because if you try to call this part of the code before, the result is this. Hey, shape, I don't know if shape has the site property in this case. And in using the typeguard, you can check and create a different branch in base of the type you expected, and you have also the benefit of, in this case, TypeScript to have all the intelligence and be sure that the type is like expected. You can do the same also with the switch in this case. For instance, we can also use switch in this case of type shape.kind. Thank you, Copilot. Case, yes, and perfect. It's the same in this case. It's important to remember when you build a typeguard, the business logic to understand if the object in input is of the type expected in output, okay, is your business. TypeScript doesn't know nothing about this. It's in this case, me as developer know that the kind equal square is the discriminator to understand if the shape is of type square. The same for other example. Okay, last, and this is a pretty difficult sometimes to understand, is the conditional type. This part are only TypeScript magic, okay? If you build this kind of stuff, after the build, everything disappears. But what is the conditional type? Let me put this in the Visual Studio Code, that is better. Imagine you have a lot of type, okay? In this case, apple, strawberry, car, truck, tomatoes, a cucumber, okay? And you have a discriminator in this example, the kind, that help you to understand the kind of this type. You can put all together, and now you have a beautiful all together that contain everything. And you want to split the type in based on the fruit, the vehicle, or the vegetable. You can do this with a simple conditional type. Conditional type is typically a generic type. In this case, as you can see, there is a generic type T. And check is like a pattern matching, okay? If T extend an object with kind fruit, okay, return this T, this generic type. Else, return never. Never, in this case, doesn't return anything, okay? What is the result? Is this, okay? Now I can call getFruit with all together, and as you can see, fruit contains only apple and strawberry because apple and strawberry is as the kind fruit, for instance. The same for the vehicle and the same for the vegetable. Typically, these functions are useful when you work with types from another library and you don't have the possibility to split the types, or you have to recreate the types. Typically, it's better to try to extract the type from the exposed type in this case. Okay, and that's it from this part. Now, the other advanced type. So typically, in JavaScript, in TypeScript, this is the common way to describe an object, okay? Typically in JavaScript you have a map with a key. In reality is a key of type string, number or symbol, and something like unknown. So you can, in this case, create an obj variable of type obj, and you can do whatever you want. There are some utility type exposed by TypeScript, and this is built in. So in this case, you can use record. In this case, using record with the string and unknown is the same of using this type, okay? Record accept the list of the possible keys and the list of the possible value. Typically, these are called mapped type. But how TypeScript create this mapped type for us? So jump back for this. You can use the keyword, the key of keyword, to extract all the name of the property of your type. What mean? If you try to call key of person, in this case, person key contain name, surname, and age. Okay, this is common to maybe you want to build something that depends on the key of your object. You can extract the key of your type. But you can also get all the possible value of your type. In this case, using person square bracket key of person, you can have that person types is of type string or a number. Okay, cool. But how can I use this to build my utility type? Imagine you have a type. Now there is also a read-only keyword. And you have the type person that have a name and surname, but I also want a read-only keyword. So you can use the person, you can call the name and surname, and then you have object.name, but the result is that you cannot reassign the name in this case. This could be created using a read-only mapped type, an utility exposed by TypeScript. You can use read-only and use only the simple type. So the result is that, okay, I use read-only and name and surname. The result is that this person read-only is like this person read-only before. Under the hood, this is what happened in the read-only utility types, okay? As you can see, this is the same structure of the index signature, okay? But with some different kind of stuff. So there is a generic T, okay? You can decide, okay, in this case is the read-only. using the plus read-only, you say, okay, I want to add the read-only keyword to every property of this type. K is a key in all the key of the generic type T, and every key has this its value. Okay, so T square bracket K, you can get the specific value of the key in that moment. Using this approach, TypeScript under the hood build a lot of utility for us. For instance, there is also a sugar syntax. If you don't want to use directly the read-only, you don't want to create your type, you can use the as const, okay? And for you, this person has the type name, so name and age with the read-only property. It's important to remember, if you use the as const, the read-only is only in the TypeScript ecosystem. So if someone decides to use person and cast with any and call name and try to reassign, it's possible. In this case, maybe it's better to use object.freeze in JavaScript if you want to be sure that the object is freeze. But you can, in this case, build a lot of utility using the index signature. For instance, you want to remove the read-only, okay? So this is the no read-only type. This is not a built-in TypeScript utility, but as you can see, it's really simple to create your own utility. The result is that, okay, I can use a new read-only with the person, remove all the read-only keyword for me, and the result is that I can now reassign the name property. Partial. As I said before, using the question mark, you can say, okay, this person contains two property, name and surname of type string, but this name and surname could be also undefined. This is the idea. So you can assign name or surname or nothing. You can use a partial to build out of the box this person without use the question mark. This is common when typically you have already a type and you want to convert this type in a type with partial type. For instance, imagine you are building a script with many options and you want that some option or all the options could be optional. Using the partial, you can describe the option partial without any problem. Partial under the hood use this strange syntax. So K in key off. Now for add the question mark, you use the plus and the question mark and the type. Pretty simple. When you know, for instance, plus and read-only and question mark, you can build whatever you want using TypeScript. Then you can also remove, if you want, the optional property. How? Using the required. In this case, if you pass in a required utility type an optional object, okay, the result is an object with all the property required. How it works? Pretty simple. Using the dash, you can remove the question mark from the type. There is a lot of many type utilities in TypeScript. In the documentation, you can find all of them. But if you want, there is also some tips in my YouTube channel where I talk about this utility. But typically, the question is, okay, but I already have a lot of JavaScript file and I want to migrate to TypeScript. My question is, good luck, typically. Why? Because it's a bit difficult sometimes. When you have JavaScript and TypeScript in the same code base, sometimes people prefer to use any, because when you import a JavaScript file in TypeScript, you lose all the IntelliSense and the strict the check. And typically, sometimes it's easier to use the any. But what you can do, this is an npm package called MIDI. I don't know if you know MIDI, but it's a package to build AWS Lambda serverless function with Node, okay? All this library is built with JavaScript, but expose a lot of .d.ts file. .d stands for definition, okay? So definition TypeScript file that looks like this, okay? It's a file with the extension .d.ts that describe the exposed function of your JavaScript code. So the result is, in this case, you have only to declare how the user can use your function if they are using JavaScript. In this case, as you can see, there is an interface for the root, and then there is a simple function we call a VS router handler that accepts a list of root and return an modifier handler. As you can see, it's the same here. So there is a function called VS root handler that accepts a list of root and expose as default the VS root handler. This is the JavaScript code with the TypeScript signature. It's important when you work in an NPM library built with JavaScript and that expose the definition file. Remember to export in the package JSON also the definition file, because this helps Visual Studio Code and also the build of the people that use your library to understand which is the right signature of your JavaScript library. If you are building a JavaScript project, don't worry, because you have to build your definition type if you want, but you don't have to expose them in your JavaScript code, in your package JSON, because out of the box TypeScript understand all the definition type globally. So if you create a definition type, TypeScript understand that is a global JavaScript, it is a global TypeScript definition that you can use it without any problem. Last thing, do you know that you can also test your type? It's not a common practice, but if you are building a JavaScript library that exposes the definition type, it's common to test also the exposed type. The standard de facto probably is this npm package called TSD, okay, that exposes some utility that check for you the type. So in this case, what you have to do is create a file with the extension -d.ts, if I don't remember bad. And you have to try to use your function without the expectation of run this code, okay? The only expectation that you have to have is that in some way check if the result, in this case of the VS router handler, is of this type. And this helps you to understand if you break the signature. It's important when you build a library, because if you break the signature, you probably break also your user. No? Okay, probably I talk for a long time, and you are boring and you want the pizza and the beer, probably. So there is a lot of other cool feature in TypeScript that can help you. Probably today I want to spend more time in the basic and the fundamental, because I notice the audience is not real an expert in TypeScript in this moment. So probably I try to give you a first look of all the ecosystem in the fundamental. But if you wanna, you can open the TypeScript documentation or Google and search for TypeScript, and you can find a lot of resources about TypeScript. Some conclusions are my personal conclusions. So why I love use TypeScript typically. They help to understand the control flow, as you can see before with the type guard on the asset, help a lot the team to understand, okay, if I'm here, I'm sure that also the code at runtime has this property, and I can call the area with for the square or for the cycle. Then can help for the documentation, but please, it's not a replacement of the documentation. You have to write your documentation also. For me, help me also for me in the future. Sometimes I develop a feature and I have to fix this feature or change the feature after month. Have the type to me help to reduce the cognitive, the way to understand what I'm thinking during the building of this code. Remember, this is important. TypeScript disappears after the build. So if you think that a variable is of type string, but then in your API return number or something different, your JavaScript code does nothing about this. You can prevent this using something like an NPM library, for instance, Dod, Valibot, or Typebox, that permit you to create a schema, okay? This schema is a real JavaScript code that you can use to validate if the API return an object as expected and in your assumption or during the development. Could be introduced by step, but I'm honest, sometimes is a nightmare. And remember, if you love JavaScript, TypeScript love it. It's not a drop-in. So this is the QR code for the slide if you want, but probably then we will publish with the Schrödinger. Okay, you understand?
Schrödinger rat.
Okay. If you want, I wrote a series about TypeScript in my DevTO account, or you can find something in my YouTube channel. These are my content. LinkedIn and Twitter are open, so if you want to chat with me or drop me a message without any problem. But I have a life, a girlfriend, so if I don't respond quickly, sorry. If you want to follow me on my YouTube channel on DevTO, feel free. And you can also blame me without any problem. Last, it's important, I work on Nearform, so if you wanna join us, this is the QR code. And that's it. Thank you again, thank you, because it's almost 8 p.m., so I know you want the pizza, also me. And thank you to AQuest and Shooter.
Shooter.
Sure. Thank you again.
Thank you, Luca. Thank you, Luca. So, as they prepared all the things, someone has some questions?
Also in Italian, don't worry.
Oh, yeah, also in Italian. Well, I'm too shy. I have one from online.
Whoa.
To be sure, are two, but one you have already talked in your session, so okay. I don't think I made so far to it. So, which was, in your experience, the benefit of using TypeScript in production? The best benefits?
Okay. The best benefit, in my case, is that if there is a new joiner in the team, okay, it's not so difficult to say to this guy, please try to take a look at this function, because the new joiner, it's able to understand what happened in the flow. If you have only JavaScript code, sometimes for instance, the parameters are like a box where you have something, but you don't know what is this something that there is inside of the box. And maybe this help the people also in the onboarding. For instance, now I'm in an onboarding of a project. The project is built in TypeScript in a part and JavaScript in the other. In the TypeScript part, I'm able to understand what happened without too much effort. In the JavaScript part, sometimes is a nightmare also for me in this case. But not because JavaScript is bad, but because it's two different mindsets sometimes. So, and if you try to think with types, probably it's easier also to create new stuff or change some stuff.
Yeah. As you see a variable named foo or Pippo, you know that is a string in TypeScript. In JavaScript, you can know as you have to search for all the code.
Or you have to go in production, call the API and check, okay, this
if there is an API.
Okay.
If there is an API.
Yes.
I know that you have talked already about that in your presentation, but what are your suggestions on handling a code-based incremental adoption of TypeScript from JavaScript to TypeScript? Of course, runaway is a possible solution.
No. There is a lot of real example of solution and project that achieve this goal. In reality, probably the real idea is, okay, we decide to move to TypeScript, okay? And first of all, you have to change the bundler in some way, because you have to use TypeScript. And the idea is, okay, I can add the TypeScript, but when I can add TypeScript, typically is when I have a new feature, I build the new feature in TypeScript without any problem. Then, if I came across on an old feature with JavaScript code, I know I have to spend a bit of time to convert this feature in TypeScript. And then also, if you are lucky, you have the test and you are sure that everything is okay. If you are not lucky, you have to check with manually, open the browser or whatever you are doing and check if all your refactor is okay. But typically is an incremental way with, okay, all the new feature should be created in TypeScript. And when I came across on an old feature, I have to focus to convert it in TypeScript. Okay. And it's important when you do this also talk with the business, because typically the business doesn't understand this kind of stuff. But you can, for instance, say, okay, we can prevent the error, or depend. It's not always a good idea move from JavaScript to TypeScript, depend on the project. But if you think is the correct solution, talk with the business and try to help them to understand why you need to move with TypeScript and not with JavaScript, and they also understand why you spend more time to create a new feature or maybe to convert another older feature.
Okay, so the conclusions of this talk is start using any.
No, if you have to use any, use JavaScript.
I'm joking. Okay, perfect. Yeah.
You told us that for build a performance library, it's better to use JavaScript. This is because the compilation time of the compilation from TypeScript to JavaScript introduce a lot of boilerplate code.
No, it's not this, but is more about probably this is the real answer. If you need to achieve performance, you have to do strange stuff with JavaScript. And sometimes do this with TypeScript is a bit a nightmare. For instance, you have to, if you have maybe a lot of dynamic object or something like this, because you know, okay, I know there is this this property in the server, but TypeScript force you to create an interface to say, okay, I need this this property in this object, but it's not always defined, depend on some stuff and so on. And typically when you work with the performance library, you want to do, okay, I know what I'm doing, I know how JavaScript work. I don't want, typically if you are building performance library, you don't take care of that, of type also, because you have other stuff in mind. And typically TypeScript is is like a blocker for build something in JavaScript for performance. Yes, you can, in reality you can also use TypeScript. It's not a problem of the compilation time, but it's more about, depend also on what, how JavaScript change your TypeScript code in JavaScript sometime. And maybe you don't want, for instance, I didn't speak about enum, but if you know TypeScript, please don't use enum, for instance. If you are a JavaScript developer and you know JavaScript, you know that enum is a simple object built with a key and a value. It's pretty simple. If you use enum in TypeScript, TypeScript convert no, it's better to show you. But if you create an enum and you forgot something like 1, 2, 3. Okay, you can build. Now they fix a bit, but this is the result, okay? As you can see, this is a problem. It's not understandable. And in reality, I can describe this in const Ludo 1 equal, come on, Copilot. This is the result. Yes. Up. Okay. As you can see, the compiler sometimes creates some stuff. But what happens if I use 1, 2, and wait, 3? Okay, I can build. And as you can see, now the result is a bit different. Where is what there 0, 1, and 2? So sometimes enum is a nightmare in TypeScript, so don't take care about enum. But sometimes when you want to achieve performance, you know what you want to do, and TypeScript is only a roadblock. And typically, if you want to build a small library, TypeScript is good enough.
Okay. Other small questions, because the pizzas is cold.
It is cold.
So no more questions. For the crowd, do you start using TypeScript now?
No, wait. Do you want to start to use JavaScript first?
Yeah. Do you want to start using JavaScript? Yeah, perfect, because it's not
TypeScript? No.
No.
Perfect.
No one.
I'm convinced.
Yeah, you haven't convinced anyone. So thanks, Luca. A big round of applause for him for coming here in Verona.